check out my cloud chamber.
Go.
Alright, so what is a cloud chamber? Small chamber filled with a supersaturated vapor of a polar molecule, in this case isopropyl alcohol. When charged particles pass through, they cause rapid condensation. They just make big cool clouds, pretty much. Here's our setup right here. This is a box with dry ice in it. On top of it, small acrylic box, aluminum panel, and on the very top we have a hot water bottle, 60 Celsius or so, full of water, and right under it are some small sponges full of isopropyl alcohol. This vaporizes because it melts, or it evaporates at a low temperature, and when it gets down here where it's about -20, it'll start to condense and become super saturated. And hold on, one more time. Here's what we found. So a lot of alpha emissions. These are pretty bog standard. These were happening all the time. They were kind of being fired off like bullets, maybe once every 1 or 2 seconds or so. You'll see when I roll some of the video later. Pretty standard stuff. This is higher energy alpha particle, and we can identify them as alpha particles because they have a very distinct cloud, because they are highly interactive, and they don't go for very far because they're highly interactive and they'll get stopped by something. Another pretty standard thing is the beta particle, just a free electron. As we know, these are less interactive than alpha particles, so they have a more faint cloud and they go on for longer. They're also wispier because electrons, being so much lighter than alpha particles, are kind of blown like a piece of paper in the wind. This is pretty cool. This is what I theorize is a double alpha emission here. That is happening because a radon-220 atom is decaying into a polonium-216 atom, which has a very short half-life and immediately decays into lead-212. So you basically get two decays at pretty much the same time. Cool stuff. Here's the decay chain right here where we can see radon-220 has a 55-second half-life. Boom, it decays into polonium-216, 0.14-second half-life, so that's decaying pretty much instantly. And now it's lead-212. It's likely what it is. Rare observations. These are pretty cool. You're not ready for this. Take a second. Okay, here we go. This, likely muon trail. This is a cosmic particle, muon from the sun, heavy electron. These, much heavier than electrons, heavy electron, as they call the nickname of a muon. So it has a lot more kinetic energy and can shoot through and leave a trail. And notice how it's nowhere near our thorium source over here, so it's completely unrelated. We got ourselves a little particle decay. This one was pretty hard to find. I had to look through like 30 minutes of videos to get this one. I only found one. I may have found another one, but it didn't look very good. This is the better one. We only found one. Here, I'll make it look more obvious here. So as we can see, the particle has its incoming trajectory, and then it splits right here off into two. Over here, we have an alpha emission that I think is from a random or stray radon-222. Why do I think it's radon-222? I looked at all the decay chains for the most common radon isotopes, and radon-222 decays into a product that has a relatively long half-life, so we don't see an immediate second decay like we did with that double alpha emission earlier. So that's why I think that's radon-222, not radon-220 or the other one. Can't remember it. This is the coolest one of all. Possible Rutherford scattering. This is an alpha particle hitting a nucleus of another atom in the air, probably nitrogen, maybe oxygen, maybe carbon, and then deflecting. Take a closer look. This is the yellow path, just to make it a little bit more obvious. Look at that. You can't tell me that's not Rutherford scattering. And it's kind of hard to tell, but I think there's a small condensation cloud right here caused by the atom being knocked. Like if you threw two pinballs together and one of them shot off to the side a bit. Recoil. That's what I'm trying to say. And this, I don't know what happened here. This is the final thing that I'm going to be showcasing. We found some pretty interesting, extraordinary decay here. This seems to be two alpha particles or two charged particles of some kind and like a beta particle by its wispiness here. So whatever this was decayed into possibly two alpha particles and an electron, and I'm not really sure what's going on here. You can be the judge on this one. You tell me. I don't know. But this is the end. The K chain image came from Wikipedia. Thank you to Sarah. The end.